Welcome to qnawire.
So the question is first asking us, will the barrel sink? So let's suppose that the barrel is completely underwater. We should first find the weight of the barrel. This is going to simply be the mass of the barrel times gravity. The mass of the barrel can be defined as the mass of the barrel itself, 15 kilograms, plus the density of the oil times the velocity of the oil within that barrel times gravity. This is going to be 15 plus 750 kilograms per meter cubed times 0.120 meter cubed times g, or rather times 9.8, the acceleration due to gravity. And we find that the weight of the barrel here is going to be 1,029 newtons. So again, we have the weight of the barrel plus the weight of the oil inside the barrel times the gravity is going to equal the weight of the barrel. Now, the buoyancy force is going to simply be the density of the water times the volume of the water being displaced and the gravitational, the acceleration due to gravity. Here, we're going to use 1,000 kilograms per cubic meter times the velocity, the volume of the water displaced is equal to the volume of the barrel. So essentially, it'll be just 1,000 times 0.12, and then again times 9.8, and this is going to equal 1,176 newtons. Now, this, because the buoyancy force is greater than the weight of the barrel, barrel will float. And then it's saying, okay, if it's going to float, what percentage of the barrel's volume will be above the water? So at this point, we can say that at rest, this barrel is not moving. So that means that the sum of forces in the y direction must equal 0. Must equal 0 newtons. And this means that the buoyancy force must equal the weight of the barrel. We know that the buoyancy force is going to be the density of the water, the volume of the water displaced times the gravity equals mg, the mass of the barrel times gravity once again. We found that the mass of the barrel, this right here, is going to be 105 kilograms. So when we solve for this, we're solving for the volume of the water, and this is going to be equal. We can cancel these acceleration due to gravity, and we simply have the mass divided by the density of the water. Here, this is going to be 105 divided by 1,000, and we have 0.105 meters cubed. So this is the volume of the water that is displaced. And the only thing that is, of course, displacing this water is the barrel. And the barrel's volume is 0.12. So that means that the volume of the barrel above water is simply 0.12 minus 0.105, 0.015. And then one can say 0.015 divided by the total volume times 100, and we have 12.5% of the barrel's volume will be above the water. So this will be the percentage of the volume that is above the water, given that the barrel is going to float. So this is part A. This is part B. And now part C is asking us a little bit different because we have different parameters. Now, the density of the oil now, instead of 750, it's going to be 910 kilograms per cubic meter. And then we have the mass of the barrel without any oil in it is going to be 32 kilograms. instead of that 15 kilograms. So here, the weight of the barrel is going to be 32 kilograms times 9.8, rather m and g. And this is going to equal 1,383.76 newtons. Now, the buoyancy force stays constant because it's not as if the volume of the barrel did not change. The only thing that changed is the mass of the barrel. So when we do the density of the water, the volume of the water being displaced, and the the acceleration due to gravity, we know that this still remains constant at 1,176 newtons. So, and because the buoyancy force is less than the weight of the barrel sinks. And because of this, we're going to have to say, if we connected a rope to the barrel on the top, and then it starts to sink, and we want to pull this barrel up from out of the water, what is the minimum tension in the rope such that the barrel will go up, essentially? So again, we need to say that if we have a barrel right here, we have a force of gravity, rather the weight of the barrel, and then we have a buoyancy force, and now we have a force tension. And we need the minimum weight such that the barrel goes up, which means that if we're going to make this barrel rise at a constant velocity, we can say that the sum of forces in the y direction is going to be 0 because there is no acceleration. And we're just trying to pull, we just want to find the minimum tension to pull this barrel up. So here it would be the buoyancy force minus the force tension, rather plus the force tension minus the weight of the barrel equals 0 newtons. Or we can say the force tension equals the weight of the barrel minus the buoyancy force. And this is going to equal 1,383.76 minus the buoyancy force of 1,176 newtons. And we find that the minimum force tension is going to be 207.76 newtons. And again, this is a minimum. So this would be the answer for part C. So again, we had to, rather, this is going to be the answer for part D. The barrel sinks is part C. We had to have assumed that the barrel was completely underwater to begin with. And then once we found out if the buoyancy force or the weight of the barrel was greater, we can tell whether the barrel will sink or float. And then if it'll sink, we can figure out a tension in a rope, in a theoretical rope, to pull it back up to the surface. And that's the end of the solution. Thank you for watching.